Hello everybody and welcome back. We're going to continue looking at the Grade 8 Gauss contest from the year 2002, and we're on to question number 12. So question 12. Which of the following can be folded along the lines to form a cube? Okay. So a picture like this, that if you can fold it into a cube or a tetrahedron or something, these are called nets. Okay, they don't come up a whole lot, but they do come up, I find, in the actual education system. They will have you cut these out and fold them all up. And, oh, look, we get a cube. Oh, look, we get a dodecahedron, that sort of stuff. And so if you've recently gone through the grade 7 or grade 8 curriculum, you've probably seen a net or done something like this, maybe even a little younger, maybe grade 5 or 6 even. And so if you have experience with nets, you're going to know that the answer here is going to be D. Okay? But let's suppose we didn't know it was D. How would we approach this question if you don't know the answer to a question on these? I very much recommend that you leave them blank and come back to them. Skip it immediately if you don't know what's going on, because even if you leave it blank, you get 2 marks. You get 2 marks for leaving something blank. They reward you for saying, I don't know. But let's say we skipped this one because we didn't know how to do it. We did the whole rest of the contest. We did it all. We're confident. And we got 10 minutes to kill at the end of the contest. We come back to 12. How would we approach this one? So we're going to have to fold along the lines, and we get cubes. So the first thing I would want to do is try and say rule out some of these possibilities. So I start to think, well, what does a cube have? Well, it's got 6 faces, 6 square faces. So I checked, do any of these not have 6 square faces? This one, A, almost looks like it might have 7, but no, it's got 6, 6, 6, 6. Okay, so each of these has 6 faces. We can't just simply rule any of them out. And we have to start thinking about other things. What you could do is, if you can, some proctors won't allow it, but some people will allow you to bring in things like a protractor or a pair of scissors would be really nice. Or even if you can just grab a piece of paper and rip out these things and try and fold them up, you could actually make little models and try and fold them in 3D to make a cube. That's a good thing to do. Easier if you're allowed to bring in scissors, even if they're safety scissors. But if we're trying to do this mentally, we want to maybe go one at a time and try and fold them. How do they fold in our heads into a cube? And that can be very hard for some people. Spatial reasoning, 3D modeling in your head is not something that we are often taught to practice. It's very hard to just conjure up a 3D image in your head. Like, try and think of an icosahedron and then rotate it in your head just mentally. That can be quite difficult for a lot of people. But we try and do that. And one of the things that I know about cubes that's going to help me here is I know that for a cube, every single corner of the cube has exactly 3 faces meeting it. Every corner has 3 faces, 3 square faces meeting at that corner. So if I were to mentally try and fold B, well, I'm going to fold along the lines, and I'm going to get corners. But let's if we just switch over and we drop B for a moment. So one of the nice things is when we fold, every single corner of one of these cube faces is going to have to correspond to a corner of our cube when we fold, which means we're going to have a corner right here, but this corner has 1, 2, 3, 4 faces meeting at it. So it's not going to give a cube. It's not a cube. Cubes have 3 faces per corner. Okay. I think there was another one I saw that also disobeys this, C. Right in the middle of C, we're going to have 4 faces per corner, and that's not going to work out. So this is why B can't work. And same right here. 4 faces meet here. So it's not going to work as well. Now that leaves us with A, D, and E, and so that's a 1 out of 3 guess if I have to make it. But well, let's think about A. So A, we actually have 4 in a row here, and if I fold those, that's going to, so let's fold this over, and so that's going to give me, sort of sticking out on the bottom is going to be 2 here, and these guys fold around. Maybe if I sort of shade them in the outsides in blue. So I've got 2 holes on either side that I need to fill up to make a cube. But if I fold along here, I'm just going to sort of double up on this top. If I fold this guy up, and we're going to have a hole here. So this also does not form a cube. Now, as I mentioned, D is the right answer. So if we try and fold D, we will be able to form a cube. But let's see for a moment why E won't work. Okay, we're looking good. I mean, here's 3 squares to a corner. Here's 3 squares to a corner. That's looking pretty good. And if we fold sort of these 3 corners together, and these 3 corners together, we're going to get corners of cubes. And we're going to get sort of so here's a corner of a cube, and then back in there. We'll fold up there as well, and there. So we're actually going to get 2 corners of cubes, but they're not going to fold together. We're going to sort of double up on it doubles up, and we're going to get a hole in back. So this one also will not work. Now I'm trying to draw these pictures, but again, as I mentioned, a lot of people have problems with 3D reasoning. And so even these little pictures that I'm drawing here, you might not be able to properly interpret them. And that is a shortcoming of the medium. I can't draw a 3D picture on a 2D flat screen. So if you're really having problems with this and trying to understand, I seriously encourage you guys to grab a piece of paper or even take a copy of this contest, enlarge those little pictures, cut them out, and try and fold them together with tape or something else, and actually see how they're fitting together, and which ones do give cubes and which ones don't. I mean, obviously, B, C, A, and E aren't going to give cubes. D is the right answer. But see why B doesn't actually give us a corner. E gives us sort of 2 cube corners that they don't fold together right. And D, as we'll see in a moment, gives us the corners of a cube, but they do fit together right. So it's 4 right down the middle. And then how exactly does their D picture look? First one on the left goes up top. So just like with E, we've got sort of these 3 are going to fold together to give a corner, and these 3 are going to fold together to give a corner. And so we'll be left with, here's an intermediate stage here. So that's this folded into this thing right here is folded into a corner here. And then we have another one of those corners in the same style as from E. And when these work, when these fold together, just use different colors here. This one is going to fold into place here and give us a little, it's going to fill in that hole. And this piece out here is going to fold on top and give us the top. And this one's going to come right up and fill in the whole cube. So it turns out D is the one who's going to give us a cube. And in fact, how about I color in my original diagram and show you where these guys go. This guy went on top. And this one here becomes the front face. And this one here becomes sort of the side face. And then we'll do the back face as lavender. And we haven't used green yet, so green will give us the bottom. And that's sort of how our cube fits together. So D is going to be the right answer. And there we go. So that question took us a little while because we were trying to explain it by maybe drawing little pictures. If your spatial reasoning in your head is much better, or you just know nets a lot better, this question probably didn't take you too long. Remember, these questions are aimed at, well, this one's aimed at the grade 8 level curriculum, so I have to assume that in 2002, nets were a common thing in the grade 8 curriculum. Whether or not they're still there now or they've moved earlier, who knows. Yeah, so that's question number 12, and we're going to take a look at question number 13, but we'll do that in the next video. Thank you guys for watching, and as always, I'll see you for more math in the next video.